Okay, hopefully you guys looked at the messages I put in the chat and saw that today we're going to start with questions over section 3.3, and we're going to cover section 3.4. And if you look at your checklist planner, you'll see that we also are going to do the skills review quiz, talk about the skills review for chapter 4. We're only doing like one section out of chapter 4, but we still are going to have a skills review for that. Yeah, the only section we do out of chapter 4 is section 4.1. So, there. So on your checklist planner, if you've been looking at that, today's Monday, October 5th. So you can see that today the new section is section 3.4, and then the skills review quiz, which counts as a quiz grade. And that particular skills review, we're going to do something a little bit different today because I'm going to have to do the timing for this test a little bit different. So I'm going to write this up here. So we're going to do the new material, you know, classes normally from 10:30 to 11:30. And what we're going to do that during that time is go over questions in section 3.4. And that's what we're going to do during that first hour. And then, you know, normally I give you a break from 11:30 to 12, but I have a meeting today at 12. So what we're going to do instead is at 11:30, I am going to stop. And what I'm going to do is I'm going to stay online while you guys go to the chapter 4 skills review. And I want you to start that. You might even be able to finish it before noon. And then from 11:30 to 12, I'm just going to stay online. And while you're working that, when you come to one you don't know how to do, I want you to pop on and say, what do these words mean? Okay. So because it's translating words into math. And so we're going to do sort of a pop-up question and answering time from 11:30 to 12. So we're going to be doing the chapter 4 skills review quiz during that time. And then we're going to be done at 12 today. So there will not be a second session for today because I have a meeting I need to go to at 12. All right. Let's get to it and talk about section 3.3 if you have questions. So give me just a minute to pull my math lab up on. And if you guys wouldn't mind, I know that for us it's called my stat lab, but for my other class it's called my math lab, and it's really the same product. So if you could just ignore it when I say my math lab, I'd appreciate it. It used to all be called my math lab, and they decided to make a particular product for statistics classes. I think because of the stat crunch thing. Okay, let's see if that looks. If you have a particular question, type it in the chat, please, from section 3.3, but which ones you'd like to go over. Pretty please. Well, since you asked so nicely, Christina. Christina says, question 9, part C. Now, I may have to go through parts A and B to get to part C, but I'll pull that up. And Christina, do you want me to do my example or do you want me to work yours? I'm not hearing you. Why aren't I hearing you?
Can you hear me better?
A little bit better, yeah. I've turned my sound up to 100%.
Okay, it's
So,
who is not question.
oh, who is not? Okay. So if you have a question that says who is not is going to be the complement of that. And anytime you're looking for the probability of a complement, then you subtract from 1. Let's do this particular question, okay? Just as a review of what we've done so far since you've asked this. This one, and Christina, do you want me to use your numbers or will it work okay if I use the ones that come up on mine?
You can use yours.
Okay. All right, so this one, we looked at this a little bit last time. It says the table below shows, so this is, let me write this up here. This is 3.3, number 9. It says the table below shows the results of a survey that asked 1,072 adults. So I'm going to just write that down. 1,072 people were surveyed if they favored or opposed a tax to fund education. And a person is selected at random from the 1,072. Complete parts A through C. And they've given me a table. So on the table, it says males, females, total. And then across the top, it's support, oppose, unsure, and total. There, so it looks like that. And the first question, the part A part says, find the probability. So I want to talk to you about what you should have shown. This happens to be one where I had you show work. Now, I told you this last week. I'm not checking the show work on these homework problems. I only put the show work on a couple of them so that you could practice using that space. So you could practice showing your work. So you could practice labeling your work. It doesn't even have to be for that question, really, but this is a pretty good one to do. So let me show you what you would do in the show work. First of all, I would label which part you're working on, and then where it says, find the probability the person opposed the tax or is female. You don't need to write out that whole sentence, but you should write it out in symbols, okay? So I'm looking for a probability of or that the person opposed the tax, so I'm going to use OPP for opposed, or, and I notice the word or, is female. Now, before I jump into my numbers, I'm going to apply the OR rule. So I go to my formula sheet. If you haven't printed off your formula sheet yet for test 2, you need to do that. We still have a little bit of time. Test 2 won't be, let's see, next Monday, a week from today. A week from today, we'll be reviewing for test 2. And I am going to put another Factorial practice quiz on there for you so that there's a few of you who had some difficulty with Factorial, a few of you who didn't take the test last time. Hopefully everybody's either here or is going to watch the recording, so you'll all get this information. And so I want to put another Factorial practice quiz on there so that you can try that again as soon as possible before taking the test, so you'll have that process down. And what I ended up doing with that Factorial practice quiz the last time is I ended up counting it. If you did it the last time, I counted it as 100 for a quiz grade just for you doing it, regardless of what grades you made on it. And so if you took it, then that helped your grade, your quiz average. And if you didn't, it didn't hurt you, but it didn't help you either. So I'm going to put another one up for test 2, and I'll make it a few questions that are like things you could expect on test 2, but I'm not going to make it super long because I don't want you to spend a ton of time on it. So I need my formula for an OR. So I'm going to just put my formula over here, the probability of A or B, just to remind you. I can get this off of my formula sheet. This would be the probability of A, OR is plus, the probability of B, and when you have a plus, you always have a minus, just in case there's an overlap. The probability of A and B, and sorry, I ran out of room there. So let's write what this would be. So our A is opposed and our B is female. So we're just applying this formula here. So we have the probability of A, probability they're opposed, plus the probability they're female, minus the probability they're opposed and female. Now I'm only going to put the numbers in my chart here that we need to answer this question. For example, the probability that they're opposed, that means I need all of the people in the opposed column. So I really need this total down here. And the total opposed was 633 on mine. That's the total opposed. So that's going to be 633 out of, remember, our total number of people was 1,072, plus the probability that they are female. So I really just need the total females on this. The total females is 570 right over here. That's the probability of female. So that's 570 of the male out of the 1,072. And then I need to subtract off where those two things overlap. So do you see I'm using this column here, and I'm talking about this row here. They overlap right here. The number in that cell right there are both opposed and female, and we've counted them twice. So I need that number. That's going to be what I subtract off. And opposed and female, it looks like it's 305 on mine. So I'm going to subtract off those 305 people that got counted twice, still out of 1,072. And this is still my A part. So, and I want you to try when you're showing your work, everybody, please practice showing your work and try using the type tool instead of the draw tool. And then this is just a matter of adding the top numbers, adding and subtracting the top numbers. We have that common denominator of 1,072. And so using my calculator, I have 633 plus 570 minus 305 is 898. And they want this rounded to the nearest thousandth, which is 3 decimal places. So I'm going to divide that by 1,072, and I get to 3 places. It's going to be 838. So I'm going to put that answer in. Okay, so that's correct. Now I'm going to go to the B part. Before I move forward, does anybody have a question about the A part? When I give you the test, if I ask you one like this and I ask you to show work, read the question carefully, because I may only ask you for work like on one part. So the instructions may say, show all the work for the A part of the question. And in that case, now you should on your paper, you should show the work for all 3 parts. But then all you have to transfer to the show work would be whatever I happen to ask for. If I ask for the work on the A part, you do not have to recopy the table. I just did that so you could see where I get my numbers. but I would expect to see this here. Okay, so I want to see where you applied the formula and then where you put the numbers in place of that. And then, of course, do the final calculation. Guys, if you've done this part right here, or even if you've done this here, if you've just figured out how to apply the OR formula, I'm going to give you a little bit of credit just for that. And then if you get this right, a little bit more credit. And then, of course, going on down the line. Now, if you go from here to here and you get it wrong because you rounded wrong, the most I'm going to take off is a half a point. Maybe not even that much. It kind of depends on how much the problem is worth. All right, so let's go to the B part. So, but I think I'll write my answer on that just in case I need it. So that was 0.838. I'm just going to leave that up there in case I need it for future reference. Let's go to the B part. And we're using this to kind of review what we've done. This was the OR rule, and then remember the time before that we had an AND rule, which involved multiplication. But the OR rule always involves addition and subtraction. So the B part on this one says, find the probability. So this is what I'm writing on my work, on my paper and in show work. Find the probability a person supports the tax or is male. Let's use different colors this time. So following my A or B rule, so that's the probability that they support plus the probability they're male minus the probability they support and are male. So hopefully you're seeing how I'm taking this rule that's on the formula sheet, and because this was an OR probability, I know I'm going to follow that rule. I just have to figure out what's A and what's B. So let's do support first. So that's this right here. There's support. So I need the total that supported, and mine that was 407. So this number is going to be 407 out of 1,072. Then the probability that they're male. So I'm only going to look at the male column. I need to know how many total males there are. 502. That's the male column. So there's the support, 407. Males is 502. So my probability that a randomly selected person from those people is male is 502 out of 1,072 are male. Minus, now I need to look to see, did I count anybody twice? And yes, I did. So remember, I'm looking for, I use support and male, and the place where they overlapped was right here. This cell right here is in the support column and in the male row. So I've counted them twice, and there's 168 of those. So I need to subtract them off because I counted them twice. That's the overlap, because being male and supporting it are not mutually exclusive, so that means there's overlap. And then I'm just going to add these. Now it's the same as the last one. Out of 1,072, add and subtract on the top. So I have 407 plus 502 minus 168 is 741. Out of, or divided by, 1,072, and that's going to round to 0.691 if I go to 3 places. Okay, and that's the right answer. I'm going to erase my work. Any questions? Okay. I'm going to erase the work. If I went too fast or you didn't get a chance to copy that and you want to copy it, then remember, watch the recording later and you can, pause it right there if you need to. Okay. Then the last one said, I see why you asked this one, Christina. It's worded a little weird. It says, find the probability that the person is not sure. Maybe we'll call that NS for short. So that's this. I think what might have been confusing is that they use different wording. Instead of saying the probability, they should have said, find the probability, is not unsure. I'm sorry, I even read it wrong. The probability that it is not unsure. Or female. So this is a good question. I understand why you asked that. You have to read it carefully. Make sure I read it. It is not unsure. Okay, well, that's the complement of unsure. So maybe I should figure out what's the probability, first of all, that they are unsure. Let's do that first. We're going to work on getting this. Now, I can still apply my OR formula. So this would be the probability they're not unsure. I might have to work on that. Plus the probability they're female. Minus the probability they're not unsure and female. And actually, there's a couple of ways you can find this probability. What we really want is the probability that they're not unsure. Could you find for me, so Christina, think about this. Could you find for me how many total people are unsure? How many total people are unsure? Where would that number be?
I don't have my problem brought up, but it's going to be that very bottom of that column. That third,
right.
yeah.
Okay, so I'll put my number in there, okay? There are 32 that are unsure total, okay? Out of 1,072. Okay, so remember, this all should add up to 1,072 here. So the ones that are not unsure, this right here, those are the ones that are either, that's these right here, the ones that either support or oppose. So think of it this way, they support, oppose, or unsure. 32 of them are unsure. These guys right here are not unsure. Does that make sense?
Yes.
Okay, so there's a couple of ways we could do this probability. One is we could do this probability that they're unsure is 32 out of 1,072. You see, that's where I got that. I could subtract that from 1 because we're doing the complement. This is like the probability of unsure complement. All right, so we could subtract that from 1, but another way we can do it is we can just add these total people that are either support or oppose. In other words, they're not unsure, they are sure, they either support or oppose. We could find that total there. So that's going to be, we could also subtract 32 from 1,072. It's another way to do it. So there's several ways to go about this. Subtracting the 32 off, I like, because that's only one thing. So 1,072, if I subtract off the 32 who are unsure, I get 1,040 that aren't in this category. That's what these two should add up to, is 1,040. So this is going to be 1,040 out of 1,072. So do you see if 32 are unsure, out of 1,072, then 1,040 are not unsure. And we're talking about all of these people here. Okay, and there's the totals. So now I know this first one, the probability that they're not unsure, that's that 1,040 out of 1,072 plus. Then I want the probability that they're female. And I've pretty much used every color here, but let's look at female. And really what I'm wanting to know, so for female, I'm just going to use that total female. I can get that pretty easily. I've done that before. The probability they're female is the total females out of 1,072. Now I've got to figure out the overlap, and I would say this is the part that's a little bit tricky. So remember, we were counting all of these people here. None of these people are unsure. And then I just counted this whole row. So what I need are the ones, these females, these people that are both female and not unsure. So I don't want these females here because they are unsure. I want those opposed and support. And the females that support were 239. So these are the ones, these females right here are the ones that were in those two columns that I was using. They've been counted twice. So I need to figure out, I need to find out how many that is. 239 plus 305 is 544. So the thing that was a bit different about that was to realize that I was using both of these columns to get the probability they're not unsure. I was only taking off these. So if I'm using both of these columns, and then my or was females, that means I used both of these females right here, and I had to add those together. And then I just do it the same from there. So add and subtract and divide by 1,072. So I have 1,040 plus 570 minus 544 is 1,066 out of the 1,072, and rounding that to 3 places. So I have that number in my calculator, 1,066. So out of or divided by 1,072.994.
Thank you.
I understand why it was confusing, and hopefully by breaking it down like this and looking at the chart that helps you see where these unsure people are. So these two have to be the unsure people. Okay? All right, let's go on to 3.4. And actually, when you did the Chapter 3 skills review, you did some things that you're going to see again in 3.4. So a little bit of it will be review. And I'm going to review you over those things. And one of them is factorial. I don't know if you remember in the skills review for Chapter 3, but one of the things we learned how to do was a weird product that we have in math called a factorial. And an example of a factorial, remember the notation for that is an exclamation point. and that was 5 times 4 times 3 times 2 times 1. So a factorial is a product where you start with the number and you count down to 1. You can actually just count down to 2 because the 1 doesn't change the product. And then you multiply those, and like for this one, that's 20 times 6, so that's 120. In general, n factorial is n times n minus 1 times n minus 2, all the way down to 1. And then the other thing we talked about is that when you see 0 factorial, that's equal to 1. So this is a review of factorials. We did this in the Chapter 3 skills review. Just as a reminder, we're going to use that, we're going to need that for what we're going to do today. In section 3.4, and the title of this section in 3.4 is probability and counting. And really we should emphasize the word counting. So sometimes in certain situations, what you need to do is figure out what your total number is. You know how on that chart they told us there were 1,072 people? Sometimes in order to do a probability, you first have to figure out how many ways can this thing happen in the first place. And I want you to remember the multiplication rule of counting that we did earlier. This was mentioned, I think, back in 3.1. And it said when you have so many ways that things can happen, this was like when we did, we had to figure out how many meals you can make. And and you have 5 entrees and 4 appetizers and 3 desserts, and you just multiply together. That's the multiplication rule of counting. And then you can just multiply how many ways the first thing can happen by how many ways the second thing. It's when you have a sequence of events. Now, to use an example for that, let's talk about, suppose you were going to manage a Little League baseball team and you want to know how many different batting orders could you possibly come up with. I'm not sure why you would want that, but we're just going to do it. Let's suppose you thought, well, hey, I'll just write down all the different batting orders and I'll see which one looks the best. Let's see, how many would you have to write down? So a weird question, but still hopefully one that you can, that kind of makes sense. So let's suppose you have exactly 9 players, 9 children on your Little League team. And so that means there are 9, and there are 9 slots to fill because in a batting order, there's always 9. And we have exactly the number of kids everybody's going to get to bat. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we have exactly 9 kids to choose from. So that means when we're choosing for the first slot, who bats first, there are 9 kids to choose from. And we're going to remember, we're going to know how many total batting orders we have. So just to give you an idea, let's suppose one of the people is Sally. So Sally can bat first, okay? And then I'd have a whole bunch of different batting orders with Sally batting first. But if Sally bats first, she can't bat in any of the rest of them. So once you have filled this spot, there are 8 children left for the second spot. And then you have filled 2 spots, so there's 7 left here. And then 6, and then 5, and then 4, and then 3, and then 2. At this point, you've used them all but 1. And if you multiply these numbers together, you will get the number of different batting orders you can come up with if you have exactly 9 kids. Now, if you have more than 9 kids, it comes out different, okay? But let's just assume you have exactly 9 kids. And I want you to notice when we do this, what we've just done here is the same thing as 9 factorial, because we did the product from 9 down to 1. Now, you can enter that in your calculator, or you can use your calculator And if you have a scientific calculator, there should be a factorial button on your calculator. So on mine, and I have the TI-32, if you want to try to do this, if I want to do 9 factorial in this calculator, I put the 9 in first, and then I go to the PRB button, which is like, it's really close to this yellow second button. And then once I click PRB, that's right here, I have 3 options at the top: NPR, NCR, and factorial. So I'm going to arrow over to factorial and I hit enter, and then my calculator will say 9 factorial. And then when I hit enter, I get this big old number. That means with those 9 children, there are actually 362,880 different batting orders to choose from. So probably writing them all down and looking to see which one looks the best, not your best option. Okay? But suppose instead you know who you want to bat in the first, say, 4 spots. So then that would be a different situation. Then you wouldn't have as many different ones. Let's suppose that you had 10 kids instead of 9, or say 11. Let's make it 11. So if we have 11 kids, and guys, that means N is 11. So we're going to be using an N and an R in this. And if we have 11 kids, that means N is 11. That's going to come into play in a minute. But I still only have 9 slots to fill. You can't let all 11 of them bat. You can only let 9 of them bat. So I still have just 9 slots to fill. 1, 2, 3, 6, 7, 8, 9. Only this time I have 11 kids to choose from in that first spot. And then I count down by 1, only this time it's not going to go all the way down to 1. It only goes down to 3. So this is not 11 factorial. Now, it's part of 11 factorial, but it's not all of 11 factorial. All of 11 factorial would have had a 2 and a 1 here. So this is leaving off the 2. So I'm getting down to here, and then I'm not multiplying by 2 or 1. Now, there is a way to represent this with factorials, though, and it looks like this. So this is part of 11 factorial, but there's part of it missing. And since this is a product, I can get this answer here by taking 11 factorial and dividing by those 2 that were missing, the 2 times 1. So that's 2 factorial. So, because I'm dividing those off. And this right here, when we want to know how many ways, so this was how many ways we can take 11 kids and arrange them in groups of 9 and order matters. Okay, let me repeat that. This is going to give us how many ways we can arrange 11 kids, take 11 kids and arrange 9 of them, groups of 9. How many groups of 9 we can make from 11 kids when order matters. And with a batting order, of course, order matters, right? We're going to look at 2 different kinds of things like this. When order matters, that's one kind of thing. There are certain situations where order doesn't matter, but with batting order, order matters. So when order matters, we have this situation where we're stopping before we run out of people, basically. So that means that would have been 11 factorial, except we didn't multiply by this. So what we've really done is we've taken the whole 11 factorial, dividing by, and basically that cancels off the 2 factorial. So it ends up being on this one, I do all those numbers there. Okay, if I had multiplied by 2 times 1, I'd have to divide by 2 times 1 to get rid of it. And that would be a lot more. Now, I'm going to stop there for a second and tell you what this is called and tell you how to do it. So when we take kinds of groups, so when we have n things, like that time we had 11 kids, and we want groups of R things. Then if we want to know how many groups of R things, in that case it was groups of 9 kids, we were making out of 11 kids, that's called a permutation. So permutations, and you are going to need to know this for the test, permutations are the number of ways R things can be chosen from N things. And here's the important part, guys. When order matters. So for permutations, order matters. Now, the notation for permutations. Looks like NPR, except that's a little n and a little r, like little subscripts on either side. Now remember what n and r are. Okay. N is your total number of things. And R is the size of the groups that you're going to make. How many you're choosing out of the N. So on that problem we just did, we would have been doing permutations of 11 kids. Our N was 11, that's our total number, and we're taking 9 of them. Our R was 9. On that example I just did, the batting order, I had 11 kids, but I'm selecting 9 of them for the batting order. And order matters, that makes it a permutation. Okay. Now the formula for this is n factorial divided by n minus r factorial. So let's do that. This is the formula, and this formula is on your formula sheet. You don't have to memorize it. You do have to know that permutations is what you use when order matters. When you're picking, when you want to know how many groups can I make from this larger group when order matters. That's a permutation. So on this one, if I want to do this one and I want to follow this rule, that gives me 11 factorial divided by 11 minus 9 factorial, which is 11 factorial over 2 factorial. Now I can write this out. I could also use my factorial button. I could get that number, it's going to be a big number, and I could divide it by 2 factorial, which is 2 times 1, which is 2. Or I can write it out. There's 11 factorial. Notice I have the 2 and the 1 on there, but I'm dividing by 2 factorial. And so what happens is this is all multiplied. So this 2 times 1 cancels out that 2 times 1. And notice what's left. That was the answer we knew was the right answer by just using the fundamental rule of counting. I'm going to show you a couple of ways to do this in your calculator. So we just talked about how you can do factorials in your calculator. So I could do 11 factorial and then 2 factorial and divide. But there's also an NPR button on your calculator. So I'm going to show you how to do that in your calculator. But if I ask you to work on one of these, this is what I want to see right here. So in your notes, make a note that this is the work that I would expect to see, so that I know you know how to apply the formula. Okay, now I'm going to show you in your calculator. Hopefully you can see this. So here's my calculator. Hopefully there's not too much of a glare on it. I'm going to turn it a little bit. You guys tell me if you can't see it, okay? So if I wanted to do this, 11p9, that's what I'm going to try to do. 11p9. So in my calculator, I'm going to put the 11 in first. Then I'm going to go to probability. That's this button, PRB. And see, NPR is the very first option. So I'm going to hit enter. So now it says 11 NPR. And then I'm going to put the 9 in. 11 NPR 9. And then I hit enter. And let me write that number down. It's a really big number. It's 19,958,400 different batting orders just by adding 2 kids to the team. That's huge. Remember, the other one was like 362,000 or something like that. If you have a graphing calculator, let me tell you where you can find that NPR button. If you have a graphing calculator, then you're going to go to, let me grab my graph. I have a graphing calculator in here. Let me see if it's working. If you have a graphing calculator, and I don't know if you're going to be able to see this or not because the screen's kind of dark, but if I have a graphing calculator, I still put the 11 in first. Let me see if I can make that brighter. I don't think so. Oh, that's a little bit better. Okay, so I put the 11 in first. And then on the graphing calculator, the NPR is found under math, which is the third one down on the left column on most graphing calculators. And then you have to go PRB. So you have to find the PRB a little bit different. You have to push math first. PRB is over at the end in the menu. And then you can see that's your factorial is option 4 and NPR is option 2. So you can either scroll down to NPR or you can just hit the 2. Notice, I don't know if you can see this, but now it says 11 NPR. And then I would put in the 9. So I do it the same way as I did that last one. The difference is in order to find that PRB, I have to go to the math button first. So I'm going to give you a chance. I want everybody to try doing this problem. I want to make sure everybody sees how to do NPR in their calculator. I'm going to check roll while you do that. And then we'll do another example of a permutation before we go on to the last thing. So when I call your name, please raise your hand. Ariana? Cecil? Kayla? Christina? Layla? Mia? Natalie? Thanks, Mia. Samira? And Stephanie Garza. Stephanie, are you there? Okay, you guys can put your hands down and hopefully I'll check on Stephanie later and see if she's there. Okay, so I'm going to do one more example with a permutation. And then then basically we're going to talk about choosing are things from in things, how many ways you can do that when order does not matter. So sometimes order matters, sometimes it doesn't. But let's just stick with order mattering for now. So for the permutations, order matters. Okay, a kind of a classic problem, and the one that I like to give on the test is, suppose you're taking out of, so say we have 25 students in the class. So N is 25 total students. And we want to choose 3 officers, but we're going to give them titles: president, vice president, and treasurer. So, and our question is, how many different groups of 3 officers can we make from those 25 people? Because they are given titles, the order matters. Because, like from this group here, if I had Ariana as president, Cecil's vice president, and Kayla as treasurer, that's considered a different group than if Cecil is president, Kayla is vice president, and Ariana is treasurer. Do you see how the order matters on that? Because they have titles, right? So this would be a permutation because order matters. And anytime they're given titles or designations of some kind, when they aren't all equal in every way, then the order is going to matter. So what we would do in our calculator, our notation, we would have 25 things, that's our N, and we're choosing 3, that's our R. So we would have 25 factorial over 25 minus 3 factorial. Or we could write it 25 factorial over 22 factorial. Now, many ways we could do this. Figure out the answer. I can multiply it out. I can do those factorials and divide, although factorials get really huge if you do that. Or I could just do this in my calculator. Now, I'm going to show you one way to do it if you didn't have an NPR button. There's a pretty easy way to do it. And let's take that 25 and count down to this bottom number and call all the rest of it 22 factorial. Then we're dividing by 22 factorial, and that cancels. And you can see that all we have to do to get the answer is just multiply 25 times 24 times 23. And that's kind of like we had 3 slots to fill. 25 for the first slot, 24 for vice president, and 23 left for secretary, because one person can't hold more than one office. So that's, notice that's what we ended up with, 25 times 24 times 23, and that would be 13,800. And if you put this in your calculator, 25p3, you should get that answer. Even though that's not the way I did it, but that's the answer you should get. Okay, so very quickly, we're going to talk about when order does not matter. When order does not matter, we call the number of groupings combinations instead of permutations. So combinations is when you're choosing R things from N things. Still, it's the same start off, the same hypothesis, same scenario. You're choosing R things from N things, but with combinations, order does not matter. And we'll talk about a couple of situations where the order doesn't matter. So, and the notation for that looks like this. NCR. And we still have n factorial. The top of the formula is the same. And that n minus r factorial is still here, but it's multiplied by r factorial. So this is the formula for combinations. Now let's talk about when would order not matter. Well, take that same situation with the 25 students, where n was 25 students in the class total. And I'm going to pick groups of 3 of them again. But this time I'm not going to give them titles. I'm just going to call them a committee. I want to pick 3 students as a committee to research something for me. Okay? So if I pick Ariana, Cecil, and Kayla, they're the same committee no matter what order I pick them in. I'm not giving them titles. They're working together as a unit. Everybody has the same responsibility. Nobody has a special name. They're just a committee. And I like using that word committee because it helps me remember, look at this, combinations is when you have a committee where everybody's the same. But permutations, and I like to look at that. Do you see how it starts with a P, and so I think of permutations? Well, that's like when you have a president, which means they have titles and the order matters. So order matters with permutations, order does not matter with combinations. And guys, both of these are just ways of finding the total number of ways something can happen. So if you were doing a probability, we would be finding the bottom number for the probability, the total number of ways that the thing can happen. Let's do this one. Say we have n equals 25 students and our R is 3, and it's a combination. We're going to do committees of 3 students. And our question is, how many can we have? How many different committees are possible? How many different committees are possible? That's the question. How many different committees of 3 people? So our R is 3 and our N is 25. Since they are committees, this is a combination because with a committee, the order doesn't matter. I'm curious if I spell that. Does committee have 2 M's, 2 T's, and 2 E's? I'm not sure about that. You know how I am about spelling. So if I've spelled that wrong, if you guys will let me know, and I'll go back and erase if I need to erase something. Because I don't like bad spelling. Okay, so I'm going to do combinations because it's a committee and the order doesn't matter. I have 25 total, so my N is 25. I'm choosing committees of 3 people, so that's my R. So following this formula, I'm going to have 25 factorial over, my R is 3, so I have 3 factorial. Your spelling is what? Thank you, Kayla. I appreciate that. Did you look it up, or you're just okay with me misspelling stuff? Either way. 3 factorial, and then I'm going to have 25 minus 3 factorial. So I would work down normally. Siri says it's right. Thanks, Mia. Well, it's got to be right then, because Siri knows everything. Okay, so on my next step, I have 25 factorial over 3 factorial times, this is times 22 factorial. And the important thing to remember here is that that's not just a 3. That's a 3 times 2 times 1. So if I was doing this one by hand, and I don't have to do it by hand because I can just put that in my calculator, but I want you to show this work right here. So in your notes, highlight that part so you'll know I need to show this work to show that you know how to apply the formula. And if you're doing it by hand, we do a similar thing we did before. We're going to count down on the 25 to one of these two, whichever one is bigger. So I'm going to count down until I get to 22. 22 factorial. I'm going to call the rest of it 22 factorial. And then I'm going to keep this 22 factorial here. Those are going to cancel. But do you see this 3 factorial right here? That's not just a 3. It's 3 times 2 times 1. So if you're doing it by hand, you can cancel out the larger of these two, but the other one has to be counted down. So notice that's actually 6 on the bottom. Now you can take that 6, this 6 right here, and you can divide it into one of these numbers if one of them divides by 6. So notice 24 divides by 6. So 6 goes into 24 4 times, and you don't have to do it this way, guys. You can punch it into your calculator at this point. But when I'm doing it by hand, this is what I do. So I'm just sharing with you. Plus, it kind of gives us practice canceling. And now to get my final answer, remember I canceled this 6 out here. I need to do 25 times 4 times 23. And that gives me 2,300. There's quite a fewer, I can't think of the right way to say that. There's way fewer committees that you can make of 3 people than there are ways to have president, vice president, and treasurer with 3 people. And that's because, like I said, like when my example, Ariana, Cecil, and Kayla, they're one committee, but I can arrange them in different orders, all kinds of ways. So there's several permutations, but they make only one committee. So what I would like for you to do, and it's 11:05 now, just as a reminder, we're not going to have a 12 o'clock session today because I have a meeting. So what I want you to do, I'd like for you to stay in the class though. Stay in the class until 12, please. And I want you to go to my math lab and work on this, okay? Work on your 3.4 homework, which is going to be things like factorials and permutations and combinations. And also I'd like for you to open up the Chapter 4 Skills Review, which is all the same kind of problem. It's all about translating words into math. So I'm going to stop the recording here.